In the 1940s, two giants battled for control of America's railroads as the industry abandoned steam for diesel power. Alco had built locomotives since 1901 and dominated steam production for decades. EMD was the upstart, backed by General Motors resources and fresh thinking. By 1955, one company would emerge victorious, while the other began a slow retreat that would end in complete defeat. This is the story of how EMD's engine didn't just beat Alco, it silenced them forever. The end of World War II marked the beginning of the greatest transformation in railroad history. Steam locomotives that had powered American railroads for over a century were suddenly obsolete, replaced by diesel-electric units that promised lower operating costs, reduced maintenance, and greater reliability. The question wasn't whether railroads would convert to diesel, it was which manufacturer would supply the engines for this massive transformation. American Locomotive Company entered the post-war era with significant advantages. Founded in 1901 through the merger of several smaller locomotive builders, Alco had supplied steam locomotives to railroads worldwide and had earned a reputation for building rugged, powerful machines that could handle the most demanding service. The company's engineering expertise was legendary, and their manufacturing facilities in Schenectady, New York, represented decades of locomotive building experience. Alco's early diesel efforts had been promising. The company built successful diesel switchers in the 1930s and had collaborated with General Electric to develop reliable diesel-electric drive systems. Their RS-1 road switcher, introduced in 1941, had proven popular with railroads that needed versatile locomotives for both freight and passenger service. The company seemed well positioned to dominate the diesel era just as they had dominated steam. The RS-1's success had given Alco confidence that their approach to diesel locomotive design was sound. The locomotive featured a straightforward layout with the diesel engine, generator, and traction motors arranged in a conventional configuration that railroad maintenance crews could understand and service. The 539 engine that powered early RS-1 units was reliable and relatively simple, characteristics that appealed to railroads making their first tentative steps into diesel operation. EMD, by contrast, was a relative newcomer to locomotive manufacturing. The Electromotive Corporation, EMC, was founded in 1922 and focused on gasoline-electric railcars before being acquired by General Motors in 1930. That same year, GM also acquired the Winton Engine Company, a pioneering diesel builder whose engines powered EMC's early diesel locomotives. GM engineers and resources then worked with Winton and EMC to develop practical medium-speed diesel designs. In 1941, GM merged Electromotive and Winton's locomotive engine division into the Electromotive division, EMD, while Winton's marine and stationary engine business continued separately as the Cleveland Diesel division. EMD's breakthrough came with the FT freight locomotive, introduced in 1939. These streamlined cabin booster units demonstrated that diesel locomotives could handle heavy freight service just as effectively as steam, while offering significant advantages in fuel efficiency and maintenance costs. During World War II, EMD built over 1,000 FT units for American railroads, establishing a strong presence in the freight market. The FT's success gave EMD valuable experience in diesel locomotive operation and maintenance. This fundamental difference in approach would prove crucial as the diesel war intensified in the post-war years. EMD's wartime production had also given them manufacturing advantages that Alco couldn't match. Their Illinois facility had been designed specifically for diesel locomotive production, with assembly lines and tooling optimized for efficient manufacturing. General Motors' financial resources allowed EMD to invest in research and development at levels that independent manufacturers like Alco couldn't sustain. Both companies entered the post-war period with strong dealer networks and established relationships with major railroads. Alco's reputation for quality and durability gave them credibility with conservative railroad managers who were skeptical of new technology. EMD's wartime success and General Motors' backing provided resources for research and development that smaller manufacturers couldn't match. The company that could best serve the needs of railroads converting from steam to diesel would dominate the American locomotive market for decades to come. The stage was set for an epic battle between two fundamentally different approaches to locomotive design. Alco's answer to the diesel challenge was the 244 engine, a powerful four-stroke design that promised to deliver the performance railroads needed for heavy freight and passenger service. Introduced in the late 1940s, the 244 was designed to compete directly with EMD's proven 567 engine, offering comparable power output in a package that Alco's engineers believed would be superior in reliability and maintenance. The 244 engine displaced 244 cubic inches per cylinder and was available in configurations from 6 to 16 cylinders, providing power outputs ranging from 1,000 to 2,400 horsepower. The engine's design reflected Alco's confidence in their engineering capabilities and their belief that railroad service demanded the most robust construction possible. The block was a massive casting with thick walls and deep skirts that provided exceptional rigidity. The crankshaft was forged from high-grade steel and supported by 6 main bearings that distributed loads evenly across the engine's length. The 244 appeared to be everything railroads needed for the diesel era. Alco's engineers had designed the 244 to incorporate lessons learned from decades of steam locomotive operation. The engine featured heavy-duty construction throughout, with components sized for long service life under demanding conditions. The fuel injection system was designed to handle varying fuel quality, and the cooling system was sized to handle continuous operation under maximum load. However, the 244 engine was rushed to market to compete with EMD's established 567, and this haste would prove costly. While the basic design was sound, the engine suffered from numerous detail problems that hadn't been fully resolved during development. Fuel injection timing was inconsistent, causing rough operation and excessive smoke. The turbocharger system was prone to failures that could disable entire locomotives. More seriously, the 244 engine suffered from fundamental design flaws that caused catastrophic failures in service. The cylinder heads were prone to cracking under thermal stress, leading to coolant leaks and engine failures. The main bearings were inadequately sized for the loads they encountered in railroad service, causing premature wear and expensive repairs. The fuel injection pumps were sensitive to contamination and required frequent adjustment to maintain proper operation. These reliability issues became apparent almost immediately as railroads began operating 244-powered locomotives in regular service. The Alco PA passenger locomotives, powered by 244 engines, suffered from frequent breakdowns that disrupted passenger schedules and damaged Alco's reputation. The PA units were supposed to demonstrate Alco's ability to build high-speed passenger locomotives that could compete with EMD's E units, but instead they became symbols of unreliability. Early RS road switchers experienced similar problems, with engines requiring major repairs after relatively short periods of service. Railroad maintenance crews reported that 244 engines were difficult to keep in proper adjustment, with fuel injection systems that required constant attention and cooling systems that were prone to overheating under load. The maintenance requirements of the 244 engine were also problematic for railroads trying to reduce operating costs. While steam locomotives had required extensive daily maintenance, diesel locomotives were supposed to be more reliable and require less attention. The 244's frequent need for adjustment and repair meant that railroads couldn't realize the cost savings they expected from diesel operation. Railroad maintenance crews who were still learning diesel technology found the 244 engine difficult to service and repair. The complex fuel injection system required specialized knowledge and equipment that many railroad shops didn't possess. When engines failed, repairs were often time-consuming and expensive, leading to extended periods of locomotive unavailability. The 244's problems were compounded as EMD's rapid investment in dealer support and parts distribution outpaced Alco's established service infrastructure, leading to increasing delays and frustration for railroads operating large Alco fleets. When 244 engines failed, railroads often had to wait for parts or technical support, extending downtime and increasing costs. Notable failures of 244-powered locomotives became legendary among railroad operating crews. PA units would fail on passenger trains, requiring steam locomotives to be called out for rescue service. RS units would break down on freight assignments, disrupting schedules and requiring expensive repairs. These failures damaged Alco's reputation and made railroads reluctant to purchase additional Alco locomotives. While Alco struggled with the 244 engine's problems, EMD was perfecting the 567 engine that would become the foundation of their dominance in the diesel locomotive market. Introduced in 1938 and continuously refined through the 40s and 50s, the 567 represented a fundamentally different approach to diesel engine design that prioritized reliability and maintainability over raw power. The engine displaced 567 cubic inches per cylinder and was available in configurations from 6 to 16 cylinders, providing power outputs from 600 to 1600 horsepower in early versions. Later developments would increase power output significantly, but EMD's initial focus was on creating an engine that could operate reliably in railroad service with minimal maintenance requirements. EMD's investment in research and development was unprecedented in the locomotive industry. The company established extensive testing facilities where engines could be operated under controlled conditions to identify potential problems before they occurred in service. This systematic approach to development allowed EMD to refine the 567 engine continuously, addressing issues before they became widespread problems. The engine's design emphasized modularity and ease of maintenance. The engine featured removable cylinder liners that could be replaced without removing the engine from the locomotive. The power assemblies, consisting of piston, connecting rod, and cylinder liner, could be removed and replaced as complete units, allowing major overhauls to be performed quickly and efficiently. This modular approach was revolutionary in locomotive maintenance. Instead of requiring extensive machine shop work to rebuild engines, railroad maintenance crews could simply remove worn power assemblies and install remanufactured units. The old assemblies could then be sent to EMD's remanufacturing facilities for rebuilding, creating a continuous cycle that minimized locomotive downtime. EMD's focus on reliability extended to every aspect of the 567 engine's design. The fuel injection system used proven technology that was less sensitive to fuel quality variations than Alco's more sophisticated systems. The cooling system was conservatively sized to handle continuous operation under maximum load without overheating. The electrical systems were designed for the harsh environment of locomotive service, with components that could withstand vibration, temperature extremes, and electrical interference. The 567 became the workhorse of American railroads through its installation in EMD's F-unit and GP series locomotives. The F units, with the F3 model introduced in 1945 as successor to the wartime FT, became the standard for freight service on major railroads. The streamlined carbide design provided excellent aerodynamics for high-speed operation, while the 567 engines provided reliable power for heavy freight trains. The GP series, beginning with the GP7 introduced in 1949, revolutionized railroad operations by providing a versatile locomotive that could handle both freight and passenger service. The hood unit design provided excellent visibility for switching operations while maintaining the reliability and power needed for road service. The 567 engine's characteristics were perfectly suited to this dual-purpose role. EMD's engines could be rebuilt in-frame with drop-in power assemblies, a capability that gave them significant advantages over competitors. Railroad maintenance crews could perform major overhauls without removing engines from locomotives, reducing downtime and maintenance costs. The standardized power assemblies meant that parts inventory requirements were minimized and maintenance procedures were consistent across different locomotive models. The company's dealer network provided comprehensive support for 567-powered locomotives. EMD established parts distribution centers across the country and trained railroad maintenance personnel in proper service procedures. When problems occurred, technical support was readily available and parts could be obtained quickly to minimize locomotive downtime. By the early 1950s, the contrast between EMD's reliable 567 engines and Alco's problematic 244 engines had become impossible to ignore. Railroads that had initially been willing to give Alco the benefit of the doubt were losing patience with the constant maintenance problems and unexpected failures that plagued 244-powered locomotives. Major railroads like Union Pacific, Santa Fe, and Pennsylvania began shifting their locomotive purchases away from Alco and toward EMD. These railroads had extensive experience with both manufacturers' products and could make direct comparisons of reliability, maintenance costs, and operational performance. The results consistently favored EMD's 567-powered locomotives. Union Pacific, which had been one of Alco's most significant customers during the steam era, began purchasing EMDF units in large numbers for their freight operations. The railroad's mechanical department reported that EMD locomotives required significantly less maintenance than comparable Alco units and experienced fewer unexpected failures that disrupted operations. Santa Fe, another major Alco customer, made a similar transition to EMD power. The railroad's experience with Alco PA passenger locomotives had been particularly disappointing, with frequent failures that required steam locomotives to be maintained as backup power. Santa Fe's purchase of EMDE units for passenger service marked a significant shift away from Alco. The Pennsylvania Railroad, America's largest railroad system, conducted extensive testing of both EMD and Alco locomotives before making purchasing decisions. Their evaluation consistently showed that EMD locomotives offered better reliability and lower maintenance costs than Alco alternatives. The PRR's subsequent orders for large numbers of EMDF units and GP7s represented a major victory for EMD. EMD's introduction of the GP7 in 1949 marked a turning point in the diesel war. This versatile hood unit locomotive combined the reliability of the 567 engine with a design that was perfectly suited to the changing needs of American railroads. The GP7 could handle freight service, passenger service, and switching duties with equal effectiveness, making it an ideal locomotive for railroads trying to simplify their fleets. The GP7's success was immediate and overwhelming. Railroads that had been operating diverse fleets of specialized locomotives found that they could handle most of their service requirements with standardized GP7 units. The economies of scale in maintenance, parts inventory, and crew training were substantial, making the GP7 an attractive choice for cost-conscious railroad managers. Alco's market share began to collapse as railroads made the practical choice to standardize on EMD power. The company's reputation for reliability, built over decades of steam locomotive production, was being destroyed by the 244 engine's problems. Railroad purchasing agents who had once automatically considered Alco locomotives were now reluctant to specify anything other than EMD power. The financial impact on Alco was severe. Locomotive orders that the company had expected to receive went to EMD instead, reducing revenue and forcing layoffs at Alco's manufacturing facilities. The company's stock price declined as investors recognized that Alco was losing the diesel war to a better-prepared competitor. Recognizing that the 244 engine had damaged their reputation beyond repair, Alco attempted to recover with the introduction of the 251 engine in the late 50s. This new power plant addressed many of the problems that had plagued the 244, featuring improved cylinder head design, better fuel injection systems, and more robust internal components that promised the reliability railroads demanded. The 251 engine was genuinely superior to its predecessor, incorporating lessons learned from the 244's failures. The new design featured stronger cylinder heads that resisted cracking, improved cooling systems that prevented overheating, and fuel injection equipment that was less sensitive to contamination. In many ways, the 251 was the engine the 244 should have been from the beginning. However, the 251 arrived too late to save Alco's position in the locomotive market. By the time the new engine entered production, EMD had established such dominance with their reliable 567 engines that railroads were reluctant to risk purchasing Alco locomotives again. The damage to Alco's reputation was too severe to overcome, regardless of the technical merits of their new engine. Railroad purchasing agents who had been burned by 244 engine failures were understandably skeptical of Alco's claims that the 251 was different. The cost of locomotive downtime and unexpected repairs had been too high for most railroads to be willing to give Alco another chance. EMD's proven track record with the 567 engine made them the safe choice for locomotive purchases. Alco's market share continued to decline throughout the 1960s as EMD solidified their dominance. Alco's locomotive division became increasingly unprofitable as orders dwindled and manufacturing costs remained high. In 1969, American Locomotive Company made the painful decision to exit the market entirely, ending nearly 7 decades of locomotive production. Montreal Locomotive Works, Alco's Canadian subsidiary, continued producing locomotives with 251 engines after the parent company's exit from the market. MLW found some success with the 251 engine in Canadian and export markets, proving that the design was fundamentally sound. However, EMD remained firmly in control of the North American locomotive market, a position they had secured through the superior reliability of their 567 engine during the crucial battles of the 1950s. The 251 engine's later success in other applications couldn't erase the fact that Alco had lost the diesel war when it mattered most. EMD's 567 had silenced Alco not through superior power or advanced technology, but through the simple virtue of working reliably when railroads needed it most. Did you work on these legendary engines? Remember when Alco and EMD battled for railroad supremacy? Share your stories about the locomotives that shaped American railroading, and tell us which engines you trusted to keep the trains moving.